A very good day. My name is Nehan Analaki Raguraman, matrix number AA241514, from course DAC 11203, Engineering Mathematics. We are from section 3 and 4, and our group number is group 8. Our lecturer's name is Mrs. Sazana binti Hasim. This is our Engineering Mathematics Semester 1, Session 2024-2025 Problem-Based Learning Project. We would like to express our heartfelt gratitude to everyone who contributed to the successful completion of this mathematics-focused problem-based learning project. First and foremost, we extend our sincere thanks to our lecturer, Madam Shazana binti Hashim, whose guidance, patience, and expertise were instrumental in shaping our understanding of mathematical concepts and their real-world applications. The constant encouragement and constructive feedback inspired us to approach challenges with curiosity and perseverance. We are also deeply appreciative of our peers, whose collaboration and diverse perspectives enriched the learning process. The open exchange of ideas, problem-solving discussions, and teamwork helped us develop not only a deeper appreciation for mathematics, but also the ability to work effectively as a team. Furthermore, we acknowledge the resources and opportunities provided by our university, University Tun Hussein On Malaysia, which played a vital role in equipping us with the tools and environment necessary to explore complex mathematical problems. The access to books, technology, and a supportive learning atmosphere made this project both engaging and insightful. Finally, we extend our gratitude to our families and friends for their encouragement and understanding throughout this project. Their support provided the motivation and balance needed to see this endeavor through. This project has been an enriching experience, fostering not only academic growth, but also critical thinking and collaborative skills. And we are deeply grateful to all who supported us along the way.
Hi, I am Arbiana binti Anim, AA 240330. So I'll begin with the introduction for this project, and I'll start with the background information. Rising sea level really causes worry to people, especially the one who live near the sea. As time goes on, constructions are greater with the combination of two elements, which is knowledge and technology. Buildings such as coastal defense are used in preventing the upcoming flood and now exist. What is the coastal defense? Coastal defense refers to the measures and strategies used to protect sea areas from natural disasters, erosion, and rising sea levels. These measures are important for coastal communities, infrastructure, and ecosystem. Structural measures are always used in coastal defense. This structure helps preventing from the impact of waves and reduce flooding because the rising of sea level. A cube-shaped concrete is the most common coastal defense that have been built nowadays.
Hi, I'm Anisha Pika binti Muhammad Nafi, AA 240341. Problem statement: cube-shaped concrete that made from cement, water, aggregates are high in durability and strength that can last for decades. Concrete can last for a long time, but it can expand due to the change of water. Concrete expands when the concrete is heat, but contracts again when the concrete is cool. Due to water absorption, concrete is slightly expanding because it absorbs water. However, the cube-shaped concrete coastal defense is being exposed to the marine environment that causes the site length expand 0.01 meters per day because the thermal expansion and moisture absorption. Without proper analysis and precautions, some blocks may undergo any structural issues.
So, the primary objective of this project is to maintain the structural integrity of the blocks over time. The specific objectives include 1. To calculate the volume of the concrete blocks increases when the side length expands 0.01 meters per day. Second, to estimate the long-term structural durability in a coastal environment that are affected by the change in the volume and dimensions of the cube-shaped concrete coastal defense. And last one is to predict precautions that can be taken in the future about the potential lack of durability and how to maintain the function of the concrete blocks. So this is the diagram. So as you can see here, this is the diagram for this project.
Next, the solution for question 1. Based on the calculation that we discussed, we got that the volume is increasing at a rate of 0.03 cubic meters per day when the site length is 1 meter. Question 2. The effects of volume changes. First, porosity and crack entrenchment. Dimensional change due to heat or moisture absorption can cause microcracks and increasing porosity. The block will easily absorb air and salt, which makes the deterioration to entrench. Next, structural integrity. The repeat volume change can also reduce the durability of concretes under load by weakening the bonds in concrete. The precautions should engineers take is: first, material selection. Use concrete for coastal areas, such as with low water to cement ratios, additive for waterproofing, and sulfate-resistant cements. Second, quality control. Perform regular inspection and ribbon hammer tests to assess compressive strength and detect early signs of deterioration. Third, design adjustment. Allow for expansion and contraction in the design by inserting connector or buffer. Fourth, protective layer. Apply a sealer or coating to minimize any salt penetration. Last but not least, environmental monitoring. These are temperature, humidity, and salt exposure.
Assalamualaikum. My name is Muhammad Hadi Syami bin Muhammad Helmi and my metric number is AA241105. Okay, for the discussion part, I will explain it. For this problem, we know that the side length of the concrete block is 1 meter and it is increasing at a pace of 0.01 meter per day. So we have to use chain rule chain rule formula that is located in chapter 3 differentiation. So, and what we get is the concrete block is increasing at the rate of 0.03 cubic meters per day. This means also that this result is using the relationship between volume and the side length of the blocks. So, this project proves to us that mathematics has a deep connection in real-life engineering problems. It also helps us understand the change of these blocks that are stored outside by using formulas and calculation to get the precise and perfect information. That's all from me.
Assalamualaikum and hi everyone. My name is Putri Zulaika binti Bahadi, nometri AA240315. My part is conclusion about the case study 7, concrete cube blocks for coastal defense. I have two key findings, that is rate of volume increase and second, impact on durability. So the first one, the volume of the concrete blocks change as the site length expand due to environment factor like thermal expansion and moisture absorption. So when the site length increase at 0.01 meter per day, the volume rate of increase depend on the cube dimension. For a site length of 1 meter, the rate of volume change is proportional to the derivative of the cube's volume formula with respect to time. So, second, impact to durability. Impact to durability, change in the block volume may compromise the structural integrity due to cracking, deformation, or reduced strength caused by environment stress like fluctuating temperatures and saltwater exposure. So, I have one significance, which is understanding the rate of volume change is critical for design blocks that can withstand environment stress while maintaining structural integrity. So, engineer must anticipate this change and apply coating or use material resistant to thermal expansion and moisture. So, anticipating concretion change arising from the evolution of the design process, case 7 studies, is essential. Engineers apply the principle of dimensional analysis to better understand the change in volume and area and optimize the structural response for durability, safety, and efficiency. This result point to the importance of selecting the right material and making design change ahead of time so the structure perform well in the decade to come.
Hai, nama saya Muhammad Syarif Arif bin Muhammad Syarif, nombor metrik AA242053. Pada hari ini saya akan membentangkan bahagian saya, iaitu reference and appendix. Untuk reference, saya ambil daripada 3 rujukan utama dan merujuk kepada UTSM Thesis Writing Guide. Seterusnya, untuk appendix kita ada fila table. Fila table tu F tu facts, I tu ideas, L tu learning issues dan A tu action plan. Itu masuk fila table. Untuk minutes of meeting, tempat kita orang berbincang. Itu untuk bahagian appendix. Okey, kita mula dengan fila table dulu. Untuk fila table, kita orang punya dasarkan soalan case study kita orang. Okey, soalan case study kita orang macam ni. Projek tanah pantai melibatkan pembinaan pahadang menggunakan blok konkrit berbentuk cube. Blok ini disimpan di luar rumah dan dimensinya berubah sedikit disebabkan oleh pengembangan haba dan penyerapan lembapan. Jurutera perlu memahami bagaimana isi padu setiap blok berubah apabila panjang sisi menggambang pada kadar 0.01 meter sehari. Okey, itu soalan case study kita orang. Apa yang kita dapat di sini ialah facts. Facts tu fakta. Faktanya ialah dimensi blok berubah sedikit disebabkan oleh fenomena ini. Seterusnya, panjang setiap blok mengembang pada kadar 0.01 meter sehari. 0.01 meter setiap hari. Itu ialah facts, fakta. Untuk ideas ni macam the reason lah sebab. Okay, the reason dia konkrit seperti kebanyakan bahan mengembang apabila suhunya meningkat. Ini kerana haba menyebabkan molekul dalam bahan berketar dengan lebih kuat yang meningkatkan jarak purata antara mereka. Akibatnya, dimensi blok konkrit bertambah termasuk panjang, lebar dan ketinggiannya. Okey, itu untuk ideas. Okey, seterusnya learning issue L. Untuk learning issues nombor 1. Learning issues ni macam apa yang kita mempersoalkan benda tu lah. Nombor 1, apakah tujuan projek tanah pantai? Kedua, bagaimanakah pengembangan haba dan penyerapan lembapan menjejaskan sifat blok? Ketiga, selama berapa hari pengembangan diperhatikan? Dan akhir sekali, berapakah jumlah peningkatan selepas 1 hari? Okey, itu untuk learning issue L. Last sekali, A. A tu ialah action plan ataupun resources needed. Okey, nombor 1 ialah action plan ni macam apa yang kita boleh lakukan lah untuk case study ni. Okey, nombor 1, gunakan konkrit berkualiti tinggi, berporositi rendah yang tahan terhadap kelembapan dan perubahan haba. Kedua, sapukan saluran kalis air untuk mengurangkan penyerapan lembapan. Ketiga, memastikan blok disambungkan dengan cara mengekalkan kestabilan walaupun gunakan dimensi kecil. Keempat, gunakan penderia untuk memantau kesan suhu dan kelembapan dari semasa ke semasa. Okey, itu untuk last kali. A, iaitu action plan ataupun resources needed. Okey, dah lengkap sudah untuk fila table. Okey, kita balik pada minutes of meeting. Minutes of meeting kita orang diadakan pada tarikh 8 Januari 2025 pada pukul 10 pagi hingga 12 pagi. Kita orang buat secara Google Meet. Okey, kehadiran semua ada iaitu Syazwan, saya sendiri, Haris, Nehan, Anis, I dan Putri. Untuk aktiviti, saya melakukan ice breaking. Untuk Haris, dia divide the job scope. Untuk Nehan pula, dia review objektif. Anis pula, dia discuss untuk the next step. Untuk I pula, dia define untuk deadline kerja ni. Untuk Putri, dia repair apa yang perlu